So part 3 is the binomial option pricing. Binomial means, so suppose we have certain spot price today. There's some possible that the price increase or price decrease, right? And then this will be at 0 times U, S0 times D will be S1. And then S2, S3, S4. Like we can increase the intervals, right? This is binomial option pricing models. If you take the investment class or derivative security class before, then you may hear about this. So option pricing may be using the binomial tree so that we can have many cases and get a price of the option. Now, because it is quite complicated, if we increase the intervals, we only focus on one interval problem, so basis of the binomial option pricing. So let's look at the example here. Suppose spot price is 112.01 cents per euro, so which means that $1, so $1.1201 per euro, right? According to Bloomberg, the volatility, which is standard deviation, is 9.682%. If the exercise price is 112 cents per euro, so $1.12 per euro, expires in 119 days, and there's a forward rate expiring in 119 days, same expiration date, we estimate that it's going to be 112.45 cents per euro. Okay. Based on this scenario, we usually use this exponential function of the sigma, which is standard deviation times square root of the t. T is actually 119 days, and 119 days is actually 119 days divided by 365. That's the t. As this u. This u is the amount of increases. So if we solve this, then the u is 1.0568. Now these usually defined as the 1 over u, and 1 over u is the 0.943. Okay. So I mean, for this class, I'm not going to argue about this u and d. I mean, you keep having these, and eventually you're gonna get very many cases so that you cover most of them. So we only cover one tree, one interval, so that it may not be that correct, but I mean, this is the start point, and even though you increase the intervals, basically the way you calculate the price is exactly the same. Just that it takes time, usually require computer programming. That's it. So I mean, just see how to get the value of the option using this tree. So let's draw the binomial option pricing. So you know the S0, the current price is 112.01. Now we know the U is 1.0568 and D is 0.9463. So at expiration date, which is the 0.3260 years, 119 days divided by 165, the price will be the current price times this 1.0568, which is 118.37. Okay. Now S dt, which is the down, if the price decline by this much, then again the spot price 112.11 and times the D 0.9463, then it will be 106. Now we know the exercise price is what? 112, right? So for call option, we only exercise it when the expiration price is above exercise price, right? So this is in the money, down is out of the money. So for call value is 0, right? It's out of money. So you are not going to exercise it. So if you have call, then it's a 0. And then if up, then it's in the money option, so you exercise it. The payoff is this price minus exercise price, which is $6.37. Okay. Now you can calculate so-called Q, because we have formulas actually to get this answer. So call option equals to CUT, which is $6.37 times Q plus CDT, 0 times 1 minus Q divided by 1 plus interest rate of the dollar. Because D is a 0, and we just ignore this, right? So calculate T, this is the formula for T, Q, I mean. It's the fourth price minus at 0 times D divided by at 0 times U minus D. Then your Q is 0.5214. So C0 equals to 637 times 0.5214 Q, and CD equal to 0. So it's going to be 0 divided by 1 plus interest rate is here 0.026, because the interest rate is the 0.26% for this 119 days. So call option price is $3.31. Okay. So that's one way to get the answer. The next one, so you can calculate Q first and then use this formula. Okay. By the way, this interest rate should be given, and the interest rate for 119 days R is 0.26% here, okay? It's a given number. Now, there's another way to calculate the price, which is which we use the hedge ratio. The hedge ratio of the option is a ratio of changing price of the option to the changing price of the underlying asset. So numerator is option changes, denominator is the price changes. So for this case, up is 637 minus 0 from the tree, right? And then 118.37 minus 106, that will be the hedge ratio, and hedge ratio is 0.5150. There's also a formula that we can use here. So it's going to be 4 times the hedge ratio minus exercise price times at 0 times U divided by exercise price times H minus 1 plus 1 divided by 1 plus R, you know, the dollar. So it looks complicated, but just do the math one by one. Plug the number into the formula, that you can get the $3.31. That's another way to get it. Yeah. So 331 here and 331 there, right? It's basically same. So you can use either way. This hedge ratio actually gives the number of unit of the underlying asset we should hold the amount of borrowing in order to create the replicating portfolio. It means that you can actually create the hedge portfolio. So and you can have actually same output at expiration date if you hold this amount of asset and have a call. So that hedge ratio. I mean, for this class, I just want you to use this formula. That's it, that's fine. The problem is real market, I mean, we have information and this call price is 276. It's far from 331. There may be some reasons. This is one, we only use one intervals, which make us like you have only 2 cases U and D. This is very dangerous because we may have another, you know, this is only 2 cases. We cannot cover most of them, right? if you increase the intervals one by one, because you can slice more, then it will cover more cases. Eventually, you may cover most of them, maybe 20 intervals. Looks like you're and making like more normally distributed function. So this is just a basic way to calculate the option pricing. Just use one intervals, but in practice, usually increase intervals and then get the price, probably more close to the call price in the market. Okay. So that's the end of this is the end of the part 3, which is binomial option pricing. Next part we'll see Black-Scholes model.